Good morning, students. So we'll do 2 or 3 more questions for differentiation of one function with respect to another function. This is a simple question. Differentiate x raised to the power 6 with respect to root x. So u is x raised to the power 6 and v is root x. So du by dx is 6x raised to the power 5 and dv by dx is 1 upon 2 root x. So du by dv is du by dx upon dv by dx. This is 6x raised to the power 5 upon 1 upon 2 root x. So this is 12x raised to the power 5 root x. If you want, you can add these two exponents, 5 plus 1 by 2, x raised to the power 1 by 2. So it comes out to be 7 upon x raised to the power 7 upon 2. Now, another one. Differentiate log x with respect to cot x. So let u is equals to log x and v is equals to cot x. Derivative of u is 1 upon x and dv by dx is minus cosec square x. So du by dv is du by dx upon dv by dx. So this is 1 upon x upon minus cosec square x. So this is minus 1 upon x cosec square x. Another one. Very simple questions actually. In board exams, you may get this of 1 mark or 2 marks. These simple questions, maybe they will be of 1 mark, or in objective question, you may get this. So differentiate e raised to the power sin x with respect to cos x. So u is e raised to the power sin x and v is cos x. Du by dx is e raised to the power sin x and then derivative of sin x is cos x. And dv by dx is minus sin x. So du by dv is du by dx upon dv by dx. So e raised to the power sin x into cos x upon minus sin x. So finally this is e raised to the power minus e raised to the power sin x into cos x upon sin x is cot x. So this is all about derivative of one function with respect to another function. Next is the differentiation of infinite series. Differentiation of infinite series. We are going to differentiate infinite series. Here we are going to, in most of the cases, we will be using logarithms on both sides. Remember one thing, this series is infinite. If we take out one term from this series, the series is unaffected. ऐसे समझिए कि समुंदर में से एक बाल्टी पानी अगर हम निकाल लें, then there is no effect on the other things. समुंदर पे कोई फर्क नहीं पड़ता है. So similarly here we will take out one term from the series and remaining series will be taken as y. So let's take this series. Y is equals to root sin x plus root sin x plus root sin x. This is up to continues up to infinity. So if we take out one term, then the series still remains same, that it is still equal to y. So here y is equals to, we are taking out only one term, this term. We are taking out this term, the remaining series is still y. So this is root sin x plus y. Now this is very simple now. It has become very simple to differentiate, squaring both sides. So y square is sin x plus y. Now differentiate both sides. This is 2y dy by dx is equals to cos x plus dy by dx. Bring the terms containing dy by dx on one side. So this is 2y minus 1 dy by dx is equals to cos x. So dy by dx is simply cos x upon 2y minus 1. Next is y is equals to x raised to the power x raised to the power x raised to the power, and the process continues infinitely. So we'll take out one term, this one. The remaining is still y. So y is equals to x raised to the power y. Taking log on both sides, log y is y log x, and now differentiate both sides. This is 1 upon y dy by dx is equals to y upon x plus log x dy by dx. Bring the terms containing dy by dx on one side. So this is 1 upon y minus log x into dy by dx is equals to y upon x. So dy by dx is y upon x into 1 minus log x. So this is y square upon x into, this is y square into x into 1 minus log x. So many times you are using differentiation using logarithms. Do all these questions in your copy. Y is equals to root x raised to the power root x raised to the power root x up to infinity. Again we are taking only one term, the remaining series is still y. So y is root x raised to the power y. Taking log on both sides. So this is log y is equals to log root x into y. So log y is y log root x. Now differentiate both sides. 1 upon y dy by dx is equals to first function into derivative of second. So this is log root x, derivative of log root x is 1 upon root x into 1 upon 2 root x plus log root x second function into derivative of first. And now bring y to this side. So this becomes dy by dx, bring the terms containing dy by dx on one side. So this is dy by dx is equals to y upon 2x 1 upon y minus log root x. So this is y square upon 2x into 1 minus y log root x. Another one, y is equals to sin x raised to the power sin x raised to the power sin x to infinity. So y is sin x raised to the power y. Taking log on both sides, log y is equals to log sin x raised to the power y. So log y is y into log sin x. 1 upon y dy by dx is equals to y first function into derivative of second, that is 1 upon sin x into cos x plus second function into derivative of first. And now bring the terms containing dy by dx to one side, this dy by dx here. So ultimately dy by dx is equals to y square cot x upon 1 minus log sin x. So this is how we differentiate infinite series. Y is equals to root x plus root x plus root x. Same thing. Take out this term and the remaining is y. So this is y is equals to root x plus y. Squaring both sides. Y square is equals to x plus y. And now differentiate both sides. 2y dy by dx is equals to 1 plus dy by dx. Bring this here. So this is 2y minus 1 dy by dx is equals to 1. So dy by dx is 1 upon 2y minus 1. The last one of infinite series. This is y is equals to x plus 1 upon x plus 1 upon x plus 1 upon x up to infinity. So this is y is equals to x plus 1 upon y. This is xy plus 1 upon y. Take y to this side. This is y square is equals to xy plus 1. So 2y dy by dx is equals to x dy by dx plus y plus 0. This derivative of 1 is 0. So dy by dx is y upon 2y minus x. Now this was all about differentiation of infinite series. The next is differentiation of parametric functions. Now first thing, parametric, what are parametric functions? When both x and y are expressed in terms of a, or you can say both x and y are functions of a third variable, t, theta, whatever you say, then these type of functions are called parametric functions and t is called parameter. Suppose x is a sine theta and y is a cos theta, then both x and y are expressed in terms of theta. So theta is the parameter and this function is called parametric function. Suppose x is a function of t and y is also a function of t, then t is called parameter and the function described like this is called parametric function. And if we want to find dy by dx, so what we do, we differentiate with respect to the third variable, that is t. So this is dy by dt and dx by dt. We find dx by dt and dy by dt. So dy by dx is dy by dt upon dx by dt, where dx by dt is not equal to 0. So the most important thing is that we differentiate the function with respect to the parameter and then we find dy by dx. Suppose, let's take a very simple question. X is equals to 80 square and y is equals to 280. So dx by dt is 280 and dy by dt is 2a. So dy by dx is dy by dt upon dx by dt. So this is 280 upon 2a upon 280. So dy by dx is 1 upon t. So it's very simple, but sometimes you get very complicated questions from this part. So let's do one more. Find dy by dx if x is equals to a into t plus sine t and y is a into 1 minus cos t. So first let's find dx by dt. A is outside the bracket. Derivative of t is 1. Derivative of sine t is cos t. So dx by dt is a into 1 plus cos t. Leave it here. And then find dy by dt. Dy by dt, y is a into 1 minus cos t. So a is constant, it is here. Derivative of 1 is 0 because this is constant. And derivative of minus cos t is sin t. Because derivative of cos t is minus sin t, so this will become positive. And now find dy by dx. Dy by dx is dy by dt upon dx by dt. So a sin t upon a into 1 plus cos t. So this is a is cancelled and sin t is 2 sin t by 2 cos t by 2 and 1 plus cos t is 2 cos square t by 2. Cancel cos t 2 by 2 cos t by 2, 2 and 2. So you get dy by dx is equals to tan t by 2. So sometimes it is simple and sometimes it is very difficult. It depends on how the function is described. Next one, x is equals to a cos theta plus log tan theta by 2 and y is a sin theta. So find dy by dx at theta is equals to pi by 4. So first let's find dx by d theta. This is a into minus sin theta cos theta. Derivative of cos theta is minus sin theta. And derivative of log tan theta by 2 is 1 upon tan theta by 2. And derivative of tan theta by 2 is sec square theta by 2. And derivative of theta by 2 is 1 by 2. So this is now A into minus sine theta plus 1 upon 2 sine theta by cos theta by 2. Here only trigonometric cancellations. जो cancel करने हैं वो cancel करके you will get this. And now you know this is sine theta. 2 sine theta by 2 cos theta by 2 is sine theta. So this is A into minus sine theta plus 1 upon sine theta. This is minus sine square theta plus 1 upon sine theta. 1 minus sine square theta is cos square theta. So A cos square theta upon sine theta. And now let's find dy by d theta. So dy by d theta is A cos theta. This is A sin theta, y is A sin theta. So dy by d theta is A cos theta. And now let's find dy by dx. It is dy by d theta upon dx by d theta. So A cos square theta, this is A cos theta upon A cos square theta. So this upon sine theta. 1 cos theta is cancelled, this sine theta goes here, so this is tan theta. And now dy by dx at theta is equals to pi by 4. Put theta is equals to pi by 4. So this is equal to 1. So you see these functions, they are easy. So not difficult, but sometimes complicated questions are there. So if you take next one, x is equals to a log t and y is equals to b sin t. So dx by dt is a upon t, derivative of log t is 1 upon t, and dy by dt is b cos t. So dy by dx is dy by dt upon dx by dt. So this is b cos t upon a upon t. So finally dy by dx is b upon a into t cos t. So that's all for today. In the next class we'll be doing more parametric functions and difficult ones. And then the last topic for differentiation is second order derivatives, that is in your syllabus. So thank you. And do all these questions. Don't forget to do these questions. Do them on daily basis. Don't leave them like that. Otherwise, your work is getting piled up. Still, few of you are not taking the classes seriously. Take them seriously. Few of you are not watching the videos. We are getting the feedback from both sides, from Google Classroom also and from WhatsApp also. But I don't want that. It will be difficult for you to complete the work when the school reopens. And it will be very difficult for you to do so many things in very less time. So take your classes, do this work on daily basis. Thank you.